Okay, Pre-Calculus Honors, Unit 1, Section 1 on angles. Your objectives is 1, to find the complement and supplement of a given angle. You'll convert between decimal degrees and degrees, minutes, seconds, and find the measure of coterminal angles. Let's start with a couple of definitions, which you'll probably recognize from geometry. The first one is angles, where two rays with a common endpoint. Your initial side, the one here in blue, is a ray sitting along the positive side of the x-axis. In trig, all of our angles will always start here. Your terminal side, the ray rotating from the initial side to create the other side of the angle. So this would be this angle here. Counterclockwise. So counterclockwise is moving this direction, and it would be a positive angle. Clockwise rotation would be a negative angle, and all this tells us is the direction it's moving in. So on this particular one, it will actually go around this way and hit there. And then on this one here, if they don't tell you, you have no way of knowing. Is it the positive angle that's less than 90 degrees? Or, being that a full circle is 360 degrees, is it a larger circle that's just under 360 degrees? So the question is, which direction is this angle actually moving? One of the things to keep in mind is that you have to be able to identify, well, which way did my angle move? So complementary angles, these again from geometry and before. Positive angles that have a sum of 90 degrees, and your supplementary angles that have positive angles that sum up to 180 degrees. There's many ways to remember complementary, supplementary, so really it's up to you to try and get that in your head. We'll work on it if we have to. So this problem here, by the way, let me point out that when they have the numbers here to the side, they were pulled from the problems that were not assigned. So if you're doing a problem that's like number 22, then you'll know that, oh, hey, let me look at number 22 again. So on this one here, what is the measure of each complementary angle with measures 3x minus 5 and 6x minus 4? Well, since we know it is a complementary angle, we know that they must add up to 90 degrees. Oh, here we go, some algebra. So that just means that 3x minus 5 plus 6x minus 40 must equal 90 degrees. So if we combine like terms, 3x plus 6x gives me 9x, and negative 5 and negative 40 gives me negative 45. This has to equal 90 degrees. Add 45 to both sides. I'm going to run out of room. Add 45 to both sides, and we get 9x equals 135. Divide both sides by 9, and we get x equals 135 divided by 9. We get x equals 15. Now this is where I'm going to point out. It says, what is the measure of each complementary angle? So they don't want to know what x is. They want to know the measure of each of these angles. So please don't forget to go back and double check. So that means 3 times 15 minus 5, and 6 times 15 minus, 6 times 15 minus 40. So 3 times 15 is 45, 45 minus 5, so 45 minus 5 equals 40. So one of them is 40, which means this guy over here must be 50. So we do 6 times 15, which is 90, and 90 minus 40 gives us 50. So our answer on this one is a 40 and 50 degree angle. So what I would like you to do now is pause your paper or your notes for a second. Try problem number 20, see how it works out for you. Okay, so now that you're done with the problem, you have worked out this problem, so let's see how you did. I want supplementary, which means they must add up to 180 this time. So I have 6x minus 4 plus 8x minus 12 will equal 180. Combine like terms. 6 and 8 is 14x. Negative 4 and negative 12 is negative 16 equals 180. So we're going to move the 16 to the other side. We get 14x equals 196. So x must be 14. But this is when I give you the little reminder. We're not looking for x. We want to know the measure of the two angles. So the first one, 6 times 14 minus 4 will give us 84 minus 4, which is 80 degrees. Ooh, let's not forget our degree symbols over here. And the other one, so the other one is 8 times 14 minus 12. And 8 times 14 gives us 112. And 112 minus 12 gives us 100 degrees. So there are those two angles. So this brings us to the third one. It says if an angle measures x degrees, how can we represent its supplement? So we have an angle, and we know that the two angles add up to 180. The question is, how can we write this? So I'm going to ask you to pause again. Pause the video, that way you can try it, and then unpause it to see what you got, if you got what you should have gotten. So now that you reconvened, we know the supplement is 100, our supplementary angles are add up to 180. If I have one angle at x degrees, I subtract it, and that will give me my supplement. I will try to remember as I go through this, make sure I circle all of the answers. So non-integer angle measures are traditionally written with minutes and seconds. So one thing to remember is 1 degree equals 60 minutes. Think of it as 1 degree being an hour. 1 hour equals 60 minutes. 1 degree equals 60 minutes. And this is the way it is read, is you got this 1 slash is read 1 minute. Now 1 minute equals 60 seconds, but we know that because we know time. And the way it is written is with the 2 marks up there. So 1 second is read this way. So this is asking you to convert each angle measure to decimal degrees, which means we want nothing but decimals. It's 133 degrees, that 133 will not change. So we have 133 degrees plus 45 out of the 60 for the other degree. And yes, you need to go and reduce this into a decimal, so calculators come in really, really handy at this time. So 45 divided by 60 gives us 0.75. So this is 133 plus 0.75, or 133.75 degrees. Okay, so this one is the same way, but now oh look, we've got seconds on here. So I'm gonna get you started and then I'm gonna ask you to pause and finish it up. So we have 165 degrees plus 51 of the 60 degrees, but now we have 9 seconds. But 9 seconds how many, out of how many minutes? Please don't go with 60. There's 9 seconds in 1 minute. And so we need to look at how many minutes are also in a degree. So this is actually going to be 60 squared. So I'm going to, at this point, pause your video and try the problem out. Try your problem out and see if you get the same answer. Okay, so you would have gotten 165 plus 51 out of 60 is 0.85 plus 9 out of 60 squared gives you 0.0025. And this is when I get to remind you to line up your decimals to add them. So in the end, you're going to get 165.8525 degrees, and that will be your answer. Okay, next little bit is they're asking you to go the other direction. So keep in mind what we've done is to go from degrees, minutes, seconds to decimals. We went through and we were dividing. So now to go the other way, we have to do a little bit more adjustments going on. Like this first one, it is 46.75 degrees. So we're looking at this going, cool, I have 46 degrees, and I have that 70.75, which is 75 out of 60. So what we really need to do here at this point is going to be, for that 75.75, this time we were going to multiply by 60. And 0.75 times 60 is going to give us 45. So we now have 46 degrees and 45 minutes. Oops. Oops. Did you guys catch that? Let's try that one again. Minutes. And there's your answer. So on this one, we got a little bit more going on because we got more going on behind the 102. So we have 102 degrees, but we have to look at the first, this 0.3771. And if we multiply this guy by 60, we get 22.626. The 22 here is your minutes. So we come over here and we go, okay, cool, I've got 22 minutes. Then you take your other decimal, 0.626, and you multiply him by 60. And you get a 37.56. And that is your seconds. 37 0.56 seconds. And there's your answer for this guy. Now be very, very cautious because a lot of people go, ooh, there's a lot of numbers here. Let me multiply by 60 squared. It's going to give you your seconds, but then you'll have to take all of those seconds and then translate as many as you can to minutes. So might as well go down to minutes, take the minutes off, take the rest of your decimal, and get your seconds off of it. Okay, how are we doing so far? Okay, let's look at the next little itty bitty bit. Okay, they're asking you to convert. I think this would be a great time for you guys to pause your test or your notes, pause your notes, and work these two problems out, and then unpause it and check your answer, see if you got the answer or not. Okay, so welcome back. Let's see how you guys did. So this would have been 34 plus 51 over 60 plus 35 over 60 squared. This would have given you 34 plus 51 over 60, which is 0.85, plus your 35 divided by 60 squared, which is 0.00972, and the 2's keep going. Add these all up, and we get 34.85972 degrees. Okay, now the second problem, did you remember what to do on this one? So you have 59 degrees, that's the easy part. And then you have to take 0.0854 and multiply that by 60. So 0.0854 gives you 5.124. Don't forget, 5 is your minutes. So now you're at 59 degrees, 5 minutes. And then you take the 0.124 and multiply it by 60 again. And you get 7.44. So this one gives us 7.44 seconds. And there's your answer. Okay, so now, oh look, they want you to actually start doing the math with these. And there's many ways to approach this. I know some students will take this and make it all decimals and then go back to decimals or back to degrees, minutes, seconds. And some do not. I am going to not convert anything. I'm going to leave it as degrees, minutes, seconds, and then go from there. So 75 degrees, 45 minutes. So I've got 75 degrees, 45 minutes, plus 83 degrees, 32 minutes. I add this up, I get 158 degrees and 77 minutes. The problem here is that you have more than 1 degree there. You have more than 60 minutes. Remember, there's a remember. 60 minutes equals 1 degree. So we have to subtract 60 minutes off of this guy and then move him over here. So you have 17 minutes and 159 degrees. Ladies and gentlemen, this would not be a correct answer. All you showed me is you know how to add common things, but that would not be a correct answer. Okay, now if you feel brave, pause for number 36 and see how you go. Otherwise, I'm going to go ahead and start working on this one. 47 degrees, 23 minutes, minus 73 degrees, 48 minutes. It's like any other negative number. You subtract them. I have a positive number, a negative number. Simply go through, subtract them, and then change the sign. Um, give it the sign of the larger. So I know this is going to be negative in the end. So I'm just going to do the 73 degrees, 48 minutes. I'm going to go ahead and throw that negative sign on him. And then 47 degrees, 23 minutes. I changed the direction on these, which means this is really the negative number plus the positive number. And we do the same thing. So on this one here, since I have a minus sign, I know to subtract. I'm going to write it up here for you. Subtract, because of this guy right here. So 8 minus 3 is 5, 4 minus 2 is 2, so I get 25 minutes. 7, this becomes a 6, so this is 6 and a 2, so I get 26 degrees, 25 minutes. This is less than 60, so we're good. There's your answer. And the last one, same kind of idea here. I have 180 degrees and I want to subtract 124 degrees, 51 minutes off of it. So I have 180 degrees and 0 minutes. And I want to subtract 124 degrees, 51 minutes. Just like anything else, this is smaller than this guy, so what I want to do is I want to borrow from him. So this 180 is going to become 179. And again, here we go. Don't forget, 1 degree equals 60 minutes. So this now becomes 60 minutes. So 60 minus 51 gives me 9 minutes. And I do the subtraction here. I get 55 degrees. And we're done, because my minutes again is less than 60. That is our answer. Okay, standard position, an angle with the vertex at the origin and the initial side on the positive x-axis. This is an angle in standard position. So you have the, I'm going to go ahead and change, I don't have a blue up here. I would go ahead and change this to blues because we had those before. The blue is always here. This is my initial side, sorry. And then the red is going to be whatever the angle is. And that, so this would be an angle in standard position. Okay, in here we have a quadrantal angles. Your quadrantal angles are 90 degrees apart, starting at 0. And this is 0 degrees here. There's 0, there's 90, 180, 270, and our 360. There it is, a full rotation around the grid. Angles in standard position whose terminal sides lie on the x or y axes. So you'll have some form of a 90 degree or 180 degrees on each of these. So these are the ones to watch out for. They are always going to be 90 degrees apart. Okay, so coterminal angles. With your coterminal angles, these are angles that are in the exact same position as before. It's just you've done a full rotation one way or the other. So on this one here, I'm starting with 57 degrees. And if I want my coterminal angles, 2 on each direction, 57 plus 360 would give me 417 degrees. And if I wanted to go another 360, I would be at 777 degrees. So this would be the equivalent, I'm going to go back here, this would be the equivalent of me starting here and then making a full rotation and stopping, or for the second time around, doing another full rotation and then stopping in the exact same spot. Now let's go backwards on these. What if I wanted to go backwards on these? Then this one would be a negative 303 degrees. And my second rotation around would give me a negative 663 degrees. Okay, no, there's a coterminal. Coterminal just means that terminal side's in the exact same spot. It's just made more rotations around. Think of it as a tire. You mark it and then you start driving. It's rotating through so many different degrees. Okay, so find the angle of least positive measure not equal to the given measure, coterminal with each angle. When we do this, you always want to get as close to the 0 to 360. So let me throw this out there. What exactly are we looking for? Let me change the width of my line so we can write more here. So what are we looking for? We want an angle between 0 and, no, that's not right. Okay, one of those times where you need to read the directions a little bit closer. Find the angle of least positive measure not equal to the given measure, coterminal with each angle. So if you're between, okay, I thought I fixed my lines here. If you are between 0 and 360, just add 360. If you are greater than 360, subtract 360. Until you get between 0 and 360. If you are greater than 360, I'm sorry, less than 360, actually less than 0, add 360 until you get to a number between, well, a number between 0 and 360. Okay, so this one here is the first one. If you're between 0 and 360, just add 360. So this is going to be 86 plus 360. So 86 plus 360 gives me 446 degrees. This one is less than 360, so I'm here. If you're less than 0, so less than 0, I want to add 360 until you get to that number. So negative 98 plus 360 gives me a number of 262. I am there between 0 and 360. The next one is larger than 360, and it's larger by 360 by quite a bit, so it's this one here. If you're greater than 360, subtract 360 until you get to 0, between 0 and 360. So I'm going to subtract 360. So 1,000 minus 360 gives me 640. Oh, but wait, I'm still larger than 360, so I have to do it again. So minus 360 gives me 280. So my answer to this one is 280 degrees. And the last one, is this really ever a large number? We have to subtract, actually it's already negative, so you're less than 0. You need to add 360 until you get to a number between 0 and 360. You know what? This is a lot between this. So, how can we do this so that we're not doing plus 360, plus 360, plus 360, and on and on and on? Take your 8,440 and divide this guy by 360. And you get 23.444444444. What did I just do? I found that there are 23 point whatever rotations to get to this number. So if I take 360 times 23, 360 times 23, I get a number of 8280. So I'm going to add this plus 8280. But when I add it to the negative 844, I get negative 160. But at least it's still a doable number. I'm still less than 0. I just know I have to add another 360. So plus 360 gives me 200 degrees. We could have done that with this one here as well. We could have done 1,000 divided by 360. We would have gotten however many in there, and we've gone from there. So we could have done this one the exact same way. Okay. So hopefully you guys are going, okay, not too bad. The algebra, the math, not too bad as we move along. Then they come in here and they go, okay, now give 2 positive and 2 negative angles that are coterminal with the given quadrantal angle. Well, that's just like the one we gave before. I want a negative angle, another negative angle, and then 180, and then a positive angle and a positive angle. So 180 plus 360 gives us 540. And then if I add 180 again, oh, I'm sorry, not 180, 360. So if I do 540 plus 360, I get to 900 degrees. Now I want to point out, did you guys catch on to this 180 is a quadrantal angle? Okay, so if I do 180 minus 360, I'm going to be at negative 180. And if I do negative 180 minus 360 again, I'm at negative 540. So now they want you to kind of go, okay, so how can I write this? Get an expression that generates all angles coterminal. So I want you guys to pause for a second, see if you can work it out before you just go, oh, let me see what Miss Harder did. See how you did. Okay, so now that you're done, let's try this out. So I have 225 degrees. It's between 360 and 0. So to get a number smaller than 225, I have to subtract. But if I want a number larger, I'm going to add. So it's going to be a plus or minus, and how much have we been adding? 360 times n. I do want to throw that n has to be on there because 360 times 1 will give us 1 rotation, 360 times 2 will give us 2 rotations, 360 times 3 will give us 3 rotations, and so on and so forth. This could have also been written up as 225 plus 360 n, but then you would have had to identify that n can be any integer. Okay, where this one here, my n value would basically have to be a positive integer. So this would be where n is greater than 0, and this one would be where n is greater than 0 or n is less than 0. Why do we not want 0 here? Well, because 0 would just get me back to the 225. It will not give me a coterminal angle. All right, so quick little quiz for you guys. Which two of the following are not coterminal with our degrees? I think we'll leave this one as a conversation piece in class tomorrow. Wanted to see the timing on this one. This timing is really, really long. So I'm going to have to watch these on the next ones. I promise I will. Okay, draw each angle in standard position, then find the distance r from the origin to the point. So I'm going to get my handy dandy lines out so I have straight lines. My y-axis, my x-axis. Ladies and gentlemen, this is just an ordered pair. I need to make sure that you understand that you're just going to plot that point, and you can estimate. You go, oh, -5 is over here somewhere, +2 is up here somewhere, so that point is somewhere around there. But I want you to draw the angle in standard position. So to make straight lines, I will go back to my lines, and I'll draw a line from the origin to that point, or through that point, whichever way you want to look at it being. And this is my angle. This is how you would draw in standard position. There it is. It went through that point. And then they asked you to find the distance r, which would be equal to the radius of a circle. But because we're coming from the origin, this is what I get to remind you guys. Distance formula. So d equals the square root, d being distance, the square root, the difference of your x's squared, plus the difference of your y's squared. But here's what's nice, is my second order pair is 0, 0. So really, this is just going to be the square root of -5 squared plus 2 squared, which gives me the square root. Okay, slight interruption there. Okay, so we get 5 squared is 25 plus 4. So our answer here would be the square root of 29. You do not have to go into a calculator and say, oh, that makes it. No, you don't have to do that. Okay, so now I know you guys are going, what? I threw a radical on you? Yes, I did. I threw a radical on you. But you should be okay with it still. So if we go in there and make our lines and something nice and pretty and straight, I'll fix it in a minute. Nice and pretty and straight. And we get our point in here. So this is 4 radical 3. Now you are going to estimate. It doesn't have to be perfect, so you go, oh, okay. And I could always throw out there, radical 3 is 1 point something. So really it's a little more than 4. So we come out here going, okay, it's somewhere around here, but oh, that negative 4 is going to bring it down here. So our point is down here somewhere. Oh, I want my line. I gotta make a line here. So if I attached it from the origin down to here, there it is, and then I can identify my angle from here. And remember, it always starts here, and it wraps around. Now, I'm still on lines. We do not know if it's a positive or negative angle, so you have to go with the assumption it's positive unless you're told otherwise. So there is standard position. There's your standard position. And then we can do the distance formula. And again, it's starting at the other point is 0, 0. So at this point, you can pause it, see how you guys do, and then check back and see what your answer is. Okay, so welcome back. And so we do the distance formula. So the distance of r equals the square root of 4 times radical 3 squared plus negative 4 squared. So 4 squared is 16, so we get 16 times 3, because radical 3 squared is 3, plus, and negative times a negative is going to give you positive, so that gives you a positive 16. 16 times 3 is 48, so we get the square root of 48 plus 16, and we add those two babies together, and we get the square root of 64, which you must clean up to be 8. Okay. Now, some people will look at this going, oh, hey, the radical 3, you get into your special triangles. We're not going to mess with those. All right, so with that much said, I do believe this was the last example. So we get a homework. This is in every other odd, so I don't want you guys panicking over it. If you do a 1 through 129 and then divide it by 4, you're going to get a reasonable number of problems. Please start the homework. I know this video was very long. I also want to point out to you guys that you will be getting this that will have your homework problems on it. And it usually will identify the page number. These are not assigning the page number, so we'll figure it out. It's the way I want homework turned in. Your name, the date, the period number, because please keep in mind I have 3 classes. But actually this is not so much so that I don't know where class this is in. You have to put the section number down. I will give it back to you even if I know what section number it is. You have to write the section number. If you don't put the rest of the assignment in there, that's no big deal. You have to show the work. Here's the problem, and then show the work. If it's a word problem, simply write word problem and write it out. But please go down the row. It's very difficult to go across and look at homework. But there you guys have it. This is the end of the video. I apologize again for it being long. For the next one, I will make sure I double check and watch this thing. Good luck.